YouTube channel, and we are here now to discuss all the chapter summary. So, chapter 1, explore the network. So, network and the internet have changed the way we communicate, learn, work, and even play. Network come in all sizes. They can range from simple network consisting of two computers to networks connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of network. The internet provides the services that enable us to connect and communicate with our family, friends, work, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It is made up of network components including end devices, intermediary devices, and network must be reliable. This means the network must be fault tolerant, scalable, provide quality of service, and ensure security of the information and resources on the network. Network security is an integral part of computer networking regardless of whether with a single connection to the internet or as large as corporation with the thousands of users. No single solution can protect the network from the varieties of threats and exist. For this reason, security would be implemented in multiple layers using more than one security solution. And network infrastructure can vary greatly in terms of size, number of users, and number of types of services that are supported. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the foundation of any network infrastructure. This chapter focuses on network as a primary platform for supporting communication. The next chapter will introduce you to the Cisco Interwork Operating System or IOS, used to enable routing and switching in the Cisco network. So, the chapter 2, configure a network operation system or IOS, Cisco IOS. Cisco IOS is a term that encompasses a number of different operating systems which run on various network devices. The technician can enter the command to configure or program the device to perform various network functions. Cisco IOS routers and switches perform functions that network professionals depend upon to make their networks operate as expected. The service provided by the Cisco IOS are accessed using a command line interface or CLI, which is accessed by either the console port, the aux port, or through SSH or Telnet. After connected to the CLI, network technician can make configuration changes to Cisco IOS devices. The Cisco IOS is designed as a modal operating system, which means a network technician must navigate through various hierarchical modes of a IOS. Each mode supports different IOS commands. Cisco IOS routers and switches support a similar model operating system, support similar command structure, and support many of the same commands. In addition, both devices have identical initial configuration step when implementing them in a network. Cisco IOS router and switches. This chapter introduced the Cisco IOS. It details the various modes of the Cisco IOS and examine the basic command structure that is used to configure it. It is it also walks through the initial settings of the Cisco IOS switch device, including setting a name, limiting access to the device configuration, configuring banner messages, and saving the configuration. The next chapter explores how packets are moved across the network infrastructure and introduce you to the rules and packet communication. So let's proceed. Chapter 3, Network Protocols and Communications. Data networks are systems of end devices, intermediary devices, and the media connecting them. For communication to occur, this device must know how to communicate. This device must comply with communication rules and protocols. TCP or IP is an example of protocol suite. Most protocols are created by a standard organization such as the IETF or IEEE. The Institute of Electrical and Electronics Engineers is a professional organization for those in the electrical engineering and electronics field. IOS, the International Organization for Standardization, is the world's largest developer of international standards for a wide variety of products and services. The most widely used network models are the OSI and TCP/IP models. Associating the protocols, the set of rules, data communication with the different layers of these models is useful in determining the devices and services are applied a specific point as data passes across LAN and WANs. Data that passes down the stack of the OS model is segmented into pieces and encapsulated with addresses and other labels. The process is reversed as the pieces are encapsulated and pass up the destination protocol stack. The OSI model describes the processes of encoding, formatting, segmenting, and encapsulating data for transmission over the network. The TCP or IP protocol suite is an open standard protocol that has been endorsed by the networking industry and ratified or approved by a standard organization. The Internet Protocol Suite is a suite of protocol required by transmitting and receiving information using the Internet. Protocols Data Units or PDU are named according to the protocols of the TCP/IP suite: data, segment, packet, frame, and bits. Applying models allow individual companies and trade associations to analyze current network and plan network of the future. So, Chapter 4, Network Access. The TCP or IP network access layer is the equivalent of the OSI data link layer or layer 2 and the physical layer or the layer 1. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. The physical components are the electronic hardware, devices, media, and other connectors that transmit and carry the signals to represent the bits. Hardware components such as network adapters or NIC, interfaces and connectors, cable materials, and cable design are all specified in standard associated with the physical layer. The physical layer standard address three functional areas: physical components and frame encoder techniques and signal method. Using the proper media is an important part of network communication. Without the proper physical connection, either wired or wireless communication between any two devices will not occur. Wire communication consists of copper media or fiber cable. There are three main types of copper media used by networking: unshielded twisted pair or UTP, and shielded twisted pair or STP, and coaxial cable. UTP cable is the most common copper network media. Optical fiber cable has become very popular for interconnecting infrastructure network devices. It permits the transmission of data over longer distance and at higher bandwidth or data rates than any other network media. Unlike copper wires, fiber optic cable can transmit signals with less attenuation and is completely immune to EMI or RFI. Wireless media carry electromagnetic signals that represent the binary digit of data communication using radio or microwave frequencies. The number of wireless enabled devices continue to increase. For that reason, wireless has become the medium of choice for home networks and quickly gaining in popular in enterprise networks. The data link has handled the exchange of frame between nodes over a physical network media. It allows the upper layer to access the media and controls how data is placed and received on the media. Among the different implementation of the data link of the protocols, there are different methods of controlling access to the media. These media access control techniques define if and how the node share the media. The actual media access control method used depend on the topology and can be physical or logical. It is the logical topology that influence the type of network framing the media access control use. One are commonly interconnected using the point-to-point hub and spoke or mesh physical topologies. In shared media LAN, and devices can be interconnected using the star, bus, ring, or extended star physical topology. All data link layer protocols encapsulate the layer 3 PDU within the data field of the frame. However, the structure of the frame and the fields contain the header and trailer vary according to the protocols. So, Chapter 5, the Ethernet. Ethernet is the most widely used LAN technology today. It is family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. For the layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the two separate sublayers of the data link layer to operate: the local link controller LLC and the MAC sublayers. At the data link layer, the frame structure is nearly identical for all bandwidth or Ethernet. The Ethernet frame structure adds headers and trailers around the layer 3 PDU that encapsulate the message being sent. There are two styles of Ethernet framing: IEEE 802.3 Ethernet standard and the DIX Ethernet standard, which is not referred to Ethernet 2. The most significant between the two standards is the addition of the start frame delimiter or SFD and the change of the type field to a length field in the 802.3. Ethernet 2 is the Ethernet frame format used in TCP/IP network as a implementation of the IEEE 802.2 and 3 standards. The Ethernet frame provides MAC addressing and error checking. The layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. Ethernet uses the address resolution protocol to determine the MAC addresses or of destination and map them against known IPv4 addresses. Each node on an IPv4 network has both a MAC address and an IPv4 address. The IP address are used to identify the original source and final destination of the packet. The Ethernet MAC addresses are used to send the packet from the Ethernet NIC to other Ethernet NIC on the same IP network. ARP is used to map a known IPv4 address to MAC address. So the packet can be encapsulated in the Ethernet frame with the correct layer 2 address. ARP relies on certain types of Ethernet broadcast messages and Ethernet unicast messages called ARP requests and ARP replies. The ARP protocol resolves IPv4 addresses to MAC address and maintains a table of mapping. On the Ethernet network, end devices are typically connected on the point-to-point basis to a layer 2 full duplex switch. A layer 2 LAN switch performs switching and filtering based on the OSI switching and filtering based on the OSI data link layer or layer 2 MAC address. A layer 2 switch builds a MAC address table that it uses to make forwarding decisions. Layer 2 switches depend on routers to pass data between independent IP and subnetworks. So, Chapter 6, Network Layers. The network layers, or OSI Layer 3, provide service to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses 4 basic processes: IP addressing for end devices, encapsulation, and a routing and decapsulation. The internet is largely based on IPv4, which is still the most widely used network layer protocol. An IPv4 packet contains IP header and the payload. However, IPv4 has a limited number of unique public IP addresses available. This led to the development of IP version 6 or IPv6. The IPv6 simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension header, and capability for per flow processing. Plus, IPv6 addresses are based on 128 bits hierarchical addressing as opposed to IPv4 with 32 bits, that dramatically increases the number of available IP addresses. In addition to hierarchical addressing, the network layer is also responsible for routing. Hosts required a local routing table to ensure the packets are directed to the correct destination networks. The local table of the host typically contains the direct connection, the local network route, and the local default route. The local default route is the route to the default gateway. The default gateway is the IP address of the router interface connected to the local network. When the host needs to forward a packet to a destination address that is not on the same network as the host, the packet is sent to the default gateway for further processing. So, routing tables entries can be configured manually on each router to provide static routing or the router's many communication route information dynamically. May communicate route information using a routing protocols. In order to router to be reachable, the router interface must be configured. To be able to specific interface, enter interface configuration mode using the interface type and number global configuration mode command. So, Chapter 7, IP addressing. IP addresses are hierarchical with network, subnetwork, and host portion. An IP address can represent a complete network, a specific host, or broadcast address of network. Understanding binary notation is important when determining if two hosts are in same network. The bits within the network portion of the IP address must be identical for all devices that the network portion of identical for all devices that reside in the same networks. The subnet mask or prefix is used to determine the network portion of an IP address. IP address can be assigned either statically or dynamically. DHCP enables the automatic assignment of addressing information such as the IP address, subnet mask, default gateway, and other configuration information. There are three types of IPv6 addresses: unicast, multicast, and anycast. If an IPv6 link local addresses enables a device to communicate with other IPv6 enabled devices on the same link and only that link or subnet. Packet with a source or destination link local address cannot be routed behind the link from which the packet originated. IPv6 link local addresses are in FE80/10 range. ICMP is available for both IPv6 and IPv4 and 6. IPv4 is messaging protocol for IPv4 and IPv6. ICMP-v6 provides the same services for IPv6 but includes additional functional. After it is implemented, an IP network needs to be tested to verify connectivity and operational performance. So let's proceed to Chapter 8, Subnetting IP Networks. So, the process of segmenting a network by dividing into multiple smaller network spaces is called subnetting. Every network addresses add a valid range of host addresses. All devices attached to the same network will have an IPv4 host addresses that one for that network and a common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the use of router. To determine if traffic is local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same thing and network portion of an address. Subnetting a subnet or using variable length subnetting mask or VLSM was designed to avoid wasting addresses. IPv6 subnetting requires a different approach than IPv4 subnetting. An IPv6 address space is not subnetted to conserve address. Rather, it is subnet to support a hierarchical logical design of the network. So while IPv4 subnetting is about managing address scarcity, IPv6 subnetting is about building the addressing hierarchy based on the number of routers and networks they support. Careful planning is required to make best use of the available address space. Size, location, use, and access requirements are all consideration in the address planning process. After it is implemented, an IP network need to be tested to verify its connectivity and operation performance. So, the chapter 9, transport layer. The transport layer provides transport-related services by dividing data received from a application into segments, adding a header to identify and manage each segment, using the header information to reassemble the segment back into application data, passing the assembled data to the correct application. UDP and TCP are common transport layer protocols. UDP datagrams and TCP segment have headers added in front of the data that includes a source port number and destination port number. This port number enables data to be directed to the correct application running on the destination computer. TCP does not pass any data to the network until it knows that destination is ready to receive it. TCP then manages the flow of the data and resends any data segments that are not acknowledged as being received at the destination. TCP uses mechanism of handshaking, timers, acknowledgement messages, and dynamic windowing to achieve reliability. The reliability process, however, imposes overhead on the network in terms of much larger segment, harder than more network traffic between the source and destination. So, in the application, data needs to be delivered across the network quickly, or if network bandwidth cannot support overhead of control message being exchanged between the source and destination system. UDP would be the developers perform transport layer protocol. UDP provides none of the TCP reliability features. However, this does not necessarily mean that the communication itself is unreliable. There may be mechanism in the application layer protocols and services that process lost or delayed datagrams if the application has these requirements. The application developers decide the transport layer protocols that best meet the requirements for the application. It is important to remember that the other layers all play a part in data network communication and influence its performance. So chapter 10, application layer. So the application layer is responsible for directly accessing the underlying process that manage the delivery communication to the human network. This layer serves as the source and destination communication across the data networks. The application and layer application services and protocols enables user to interact with the data networks in a way that is meaningful and effective. Application a computer program with which the user interacts and which initiate the data transfer process the user request. Services are background programs that provide the connection between the application layer and the lower layer of the networking model. Protocol provides a structure of agreed upon rules and processes that ensure services running on one particular devices can send and receive data from a range of different network devices. Delivery of the data over the network can be requested from server by a client or between devices that operates in P2P arrangement. In P2P, the client-server relationship is established according to which device is the source of the destination that time. Messages are exchanged between application layer services at each end device accordance with the protocol specification to establish and use this relationship. Protocols like HTTP, for example, support the delivery of web page to end devices. SMTP, IMAP, and POP support sending and receiving email. SMB and FTP enables users to share files. P2P application make it easier for customer and seamlessly share media is in a distributed fashion. DNS resolves the human readable name used to refer to network resources into numeric addresses usable by the network. Clouds are remote upstream location that store data and host applications so that users do not require as many local resources, and so that user can seamlessly access content on different devices from the application. All of these elements work together at the application layer. The application layer enables users to work and play over the internet. So, the last chapter is Chapter 11, build a small network. In order to meet user requirements, even small network require planning and design. Planning ensures that all requirements, cost factors, and development options are given due to consideration. An important part of Network design is reliability, scalability, and availability. Supporting and growing a small network requires being familiar with the protocols and network application running over the network protocols. Analyzer enable a network professional to quickly compile statistical information about the traffic flows on a network. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic as well as the type of traffic being sent. This analysis can be used by a network technician to make decisions on how to manage the traffic more efficiently. Common network protocols include DNS, Telnet, SMTP, POP, DNCP, HTTP, and PF and FTP. So network must also be protected from network attack. Network attack can be classified into three major categories: reconnaissance, access attack, and denial of services. There are several ways to protect network from attack: authentication, authorization, and accounting, or AAA or AAA. Network security services provide the primary frameworks to set up access control on a network device. AAA is a way to control who is permitted to access a network, what they can do while they are there, and to watch the actions they perform while accessing the network or accounting. A firewall is one of the most effective security tools available for protecting internal network users from external threats. A firewall resides between two or more networks and controls the traffic between them, and also help prevent unauthorized access. To protect network devices, it is important to use strong password. Also, when accessing network devices remotely, it is highly recommended to enable SSH instead of the unsecured telnet. Then, after the network has been implemented, a network administrator must be able to monitor the maintain network connectivity. There are several commands available toward this end. For testing network connectivity to local and remote destination, commands such as ping, telnet, and traceroute are commonly used. On Cisco iOS devices, the show version command can be used to verify and troubleshoot some of the basic hardware and software components used during the boot process. To view information for all network interfaces on the router, the show IP interface command is used. The show IP interface brief can also be used to view more abbreviated output than the show IP interface command. Cisco Delivery Protocols, or CDP, is a Cisco proprietary protocols that runs at the data links layer. Because CDP operates at that data link layers, two or more Cisco network devices, such as router that supports different network layer, protocols can learn about each other even if layer 3 connectivity does not exist. Cisco iOS configuration files such as startup config or running config should be achieved. These files can be saved to a text file or stored on a TFTP server. Some models of routers also have a USB port, and file can be backed up to the USB drive. If needed, this file can be copied of the router and the switch from the TFTP server or USB drive. So this is the summary of CCNA chapters.